Okay, so now let's go to number 5. You can call this one 4B. This was just along the line I added. So number 5, CH3. So the usual, you go to CH3, C, 3 hydrogens as H, C, 2 hydrogens. Then the last chain goes to link the next carbon, which has hydrogen at the top and ethyl, C to H5 at the bottom. That is C to H5. I've combined it. You know we use it here, so I combined it. Then we go to C, H, the next C, H, then the last one C, H. So how do you name this one? The longest continuous chain, this one, and its substituent is attached to the chain, so you can pick it as the longest continuous chain because the only substituent we have, C to H5, is linked to it. Or we go from here 2, 3, 4. So don't assume, because if I had written C3H7 here, you would have said this is the longest. But if you expand the C3, C 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. You see that this one will be the longest. So don't assume. But because I had known that it's only just 2 C's, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So they are the same. That's why I picked this one. You understand? The scope is this was where they branched. It was 2 at the back. It was also 2. So it will be the same thing. Are we good to go? So H. So this is still hexane. Now the position 1, 2, 3 from the front. 1, 2, 3, 4 from the back. You see this one differs now. 3 from the front, 4 from the back. So you go with the lowest. That's the 3 from the front. That's the 3 2 carbon atoms, C to H5. That is ethyl. You're not doing written. If you are doing written, they check this your writing very well because there has to be no space. So 3 ethyl hexane. Are we good to go? So let's go quickly to the 6th one. So the 6th one, you have CH3. C. The 2 bond, one contains H, another contains Br. CH2, that is HH, then CH3. So this is simple. So pause the video and name it. Then the name, you're back. This is longest chain that has other substituent attached to it. That is just butane in family, alkane family, and just 4 carbon atoms. So butane, then position 1, 2. The only substituent you have is bromine. You know, after the family, after the longest and the long chain, as you get the family, you name it. Then where is the substituent? Just Br. All these are hydrogen. So Br, what's the position? 1, 2, 1, 2, 3. So we go to the lowest 2 bromobutane. Are we good to go? So for the number 7, quickly taking that. So number 7, you have CH3. So C, 1, 2, 3, 4. Another C, 1, 2, linked to the last C. So for the case of this one, you have 3 carbons, 1, 2, 3. The first one has 3 hydrogens attached to it. This is number 7. The second one has 2 hydrogens. The next one has 2 hydrogens and 1 iodine. So this is longest chain. The family is alkane. The long chain propane, because 3 carbon atoms. Then the substituent, this is iodine. So we call it iodo. You know, from the front, 1, 2, 3. It is 3 from the front. From the back, it is 1. Are we good to go? So 1 is the lowest. I was supposed to say 1 iodopropane, but you don't need to say 1 iodopropane. It's just iodopropane. The reason is because it should be 2 iodopropane. So you could say 1 iodopropane, but normally we just call it iodopropane. Not putting 1 there tells you it is 1. Do you understand? But that is if you check the option. Then go and see it. Once you check the option and you see that okay, there's iodopropane. But you put 1 iodopropane. You don't put, but that one, it works in other places though, especially in our alkane family. You have to specify that it's a 1. But this one, you are still good to go. You can call it iodopropane, or better, 1 iodopropane. Now let's go to question number 8. Question number 8. I'm telling you that in case there is no option for 1 iodopropane, what you see there is iodopropane. Other things 2, 3, 4, iodopropane. So it is 1 iodopropane. Let's go. Question number 8, CH3C. So let's draw this carbon, to the next carbon. That is CH3. 1, 2, 3. Then you can see a double bond at this front, a double bond. So if there's a double bond here, let's count how many bonds this carbon has had. 1, 2, 3. So it remains only one more to be complete. That was why they put just a single H here. So this next carbon coming here already has 2, and it will be linking to the next one with 1. That's this carbon. It already has 2, and it's linking to the next one. So you can see it's only one H it is also having. Because 1, 2, 3. So it only needs one more to be formed. Then this next carbon now takes this one it is receiving from the carbon before it and gives this next one a bond. So there's still 2 spaces left for it. Then this last carbon only takes in 1 from the left, so it still has 3 left. Do we get it? Now let's name this. What family? Once you're seeing a double bond, just a double bond, you know that alkene family. So the long chain, 1, 2, 3, 4, 5. There's no other substituent. You know, this is the chain, and there's no other carbon or chlorine or other element aside hydrogen that is there. So just pick it. This is 5. Are we good to go? So that is 5. That is pent. Now we are not in alkane any longer where turning it will not change anything. If I turn this one now, you will bear me witness that there will be 3 C's before a double bond. But right now there are 2 C's before a double bond. But if you lateral inversion, if you laterally invert it, there will be 3 C's before you get to a double bond. So you see that the direction to which you are coming from matters here. So this one you have to tell us the position of the bond. So this is 1, 2. The bond is after carbon number 2 from the front. From the back, 1, 2, 3. You count 3 carbons before you get to the bond. Yeah, don't get it confused. You just need a carbon that is closest to the bond. So carbon number 2 is closest to the bond from the front. From the back, carbon number 3 is already beside the bond. You don't need to cross to carbon number 4 before you get to the bond. Once you're on carbon number 3, your hand can touch the bond. You get? So 2, 3, which is closer, that should be 2. Okay, so you call it pent 2 in. Once you are putting a numbering, in between a bond, you are trying to tell us the location of that bond, the position of that bond. So you cannot say 2 pentin. No, pent 2 in. I'm telling you, this in is on position number 2. Do you understand? So if there's a substituent, let's assume there's a substituent here. I've removed hydrogen. I place the substituent instead. So this will be chloro. 1, 2, 2 chloro. So these 2 talks about chloro, but these 2 talks about the pentin. Do we understand that? But don't worry, let's take the next question so you can get. So let me change this back to hydrogen. Then you have pentin in. Now question number 9. Question number 9 says HC. Okay, now let's draw it. C triple bond. 1, 2, 3. Definitely, this carbon only has one more, bond, one more electron to bond it, and that's why you have this H. This next one takes it. It already has 3 from this one coming here, so it means if it gives to another carbon, it cannot have anything here again. So this C takes it, gives to this one, it has 2. So what are those 2? H and this C here in bracket. So this one last C takes what is given here and gives these 3. So let's name this. What family is this? Alkyne triple bond. So alkyne, the chain, this chain. These are even simple questions. So this chain and all the substituents are attached to it. Chlorine is even the only substituent here, so it is attached to it. So that's the long chain. Let's name it 1, 2, 3, 4. Kyne family. The 4th member. What's the 4th member? That's the 4th member is butane. So butane. But because you want to specify the position, but1 I. Are we good to go? And note, it is 1 from the front, it is 3 from the back. That's why you went with 1 high. That's why you went with front, because the front position gives you the lowest number. Now, for bonds like double bond and triple bond, once you had picked a direction for your bond, any naming you want to name has to start from that direction. What I'm saying is, here you pick 2 for it. Do you understand? So 1, 2, because it's the lowest. 1, 2, 3. So you pick 2. Anywhere there is substituent on this chain, you always start from the front. You don't have the choice to start from front or back again. No, because the father of the house, that is, which is the bond, the main person in the house, which is the bond, you have said this person is entering through the front door. Every other member of the house must enter through that front door. Unlike in alkane where everybody is equal. Probably that is English output. So if anybody enters at front, anybody can later decide to come at the back. At the end of the day, we just want to know which one will be easiest, to afford. after calculating the amount each person will spend on entering the house. But this one, once the main decider of the house, these two, enter through that place, we do not look at the cost again for other people if they enter through the back. No, every one of us will pass through the front. If it is the back the person is considering first, everybody is considering the back as well. So for this, butane starting from the front, because that front gives it its location. Number one, after the first carbon atom, I can touch the triple bond. Every other thing you want to name, be it chlorine. Oh yeah, look at this chlorine. 1, 2, 3. This is on position number 3 from the front. 1, 2. This is on position number 2 from the back. Which one is smaller? Smaller. Is it not position number 2? But because butane has chosen that it is the front I am passing through because of this bond. Because of this bond, chlorine has no choice than to pass through this front. 1, 2, 3. So you go with 3 instead of 2. So note for other families, other homologous series like King, Ins, Heinz, All, and Co. Once you decide for the family, the bond for the family, either it's front or back, other substituent takes that same position. Are we good to go? So now let's go. This is 1, 2, 3. That will be 3 chloro put 1 iron. The only thing we do not put position for, let's say, is propene now. You know this is propene. You don't need to say prop 1 iron. Why? Because 1, 2 from the back, 1 from the front. Do you understand? If the bond is not here, if it is here, it is still 1 from the front. So you can never have prop 2 iron. Can you have prop 2 iron? This is prop M. You can never have prop 1 and 2 in. This is prop 1 in from the back. If you put it here, it's still prop 1 in. So many times you cannot see them writing prop 1 in. They just write propene. Because you can never have prop 2 in. The only thing you can have for prop is prop 1 in or prop 1 iron. Do you understand? But starting from boot, pens, you can have 2 of it. You can have 3 of them, 4 of them. So you have to tell us the position. Are we good to go? So like this pen 2 in now, I might remove this bond and put it here. Will it be pen 3? No. 1, 2, 3 from the front, but it is 1, 2 from the back. But if it is X, you can have X2 in, X3 in, but you can't have X4 in because from the back it will be X3 in. Are we good to go? Now let's take the 10th one. So this one is already given in this expanded form. Let's just name it. The longest chain 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is the longest, and that's all the substituents linked to it. You circle this now. The substituent Cl is the substituent, it is linked to it. Br is the substituent, it is linked to it. CH3 is the substituent, it is linked to it. So what's the name of this? 1, 2, 3, 4, 5. This is pent. Pent what? In family. So 1, 2, 3, 4. Pent 4. 1 from the back. Pent 1. So the lowest is what? Pent 1 in. Since you are, because of the bond, taking the direction from the back, any other thing you want to name has to be from the back. So every of these substituents, look at the substituents, methyl, bromine, chlorine. You don't need to be considering them from the front again, whether they are low or not low. Of course, they are low from the front. 1, 2, 2, 2, 2, 3, or like 1, 2, 3, 4, 4. But because you have named this double bond from the back, that should be from the back everything. So methyl 1, 2, 3. So methyl is 3 methyl. Bromine is 4, 1, 2, 3, 4. 4 bromo, 4 chloro. You don't need to consider them from the front because the main decider in this family has already gone from the back because it is the lowest from the back. So now let's arrange them alphabetically. We have B, C, M, A, B, C, D. So B comes first. So you should have 4 bromo, a comma, 4 chloro. You can see it's a dash before. Learn this because they might give you the same answer. They'll just change this syntax we call it now. Yes, comma or dot or full stop. Just change it in different order and actually pick it. So if you don't know the arrangement, you might know the answer but not get the correct arrangement and still end up listening. So 4 bromo, 4 chloro, then 3 methyl. Then we go to 1, 2, 3, 4, 5. Pent 1 in. Pent 1 in. Capital letter. So pent 1 in. Are we good to go? That's it. Okay, so these are the set of questions we'll be taking, to get a better understanding. The first one, let's draw it out. OH, CH2. So we know OH cannot begin. Definitely it's the carbon that begins, number 1. Then it has 3 bonds. OH takes 1. Then the remaining 2 bonds left will be for H. It passes the fourth one to another C. The C passes to another one. So this C now, it has only 2 bonds again that can. One is for H, the other is for OH. Then this last C, it has one that links it and 3 other bonds. Then 2 are for H, the other one is OH. So how do you name this? the first thing, the family. Since you are seeing OH, leave this one I wrote here. I will explain it to you later. The reason why you have, okay, let's name this first, then I will explain this later. So the family you have here is the all family, alkanol family, because you have OH, but you're having 3 of it. You get, so you have gotten the family, the longest continuous chain, that is this carbon. There's no substituent, longest continuous chain. And now let's name it. That will be propanol. Abi, but you have 3 of those oils, so you have to tell us the positions of those 3. No, you have to be propan triol, 3 oils, but you have to tell us the position. So it has to be propan. You know, OH is in the first carbon atom, it is in the second carbon atom, it is in the third carbon atom. That makes it propan 1, 2, 3 triol. That is the 3 oils I have. They are on position number 1. Another is on position number 2. Another is on position number 3. And even this OH is here now. It will be 1, 2, 2. Do you understand? That's the position. It's just like when you have this. Let's assume you have this in the in family. You know, 1, 2, 3, 4. It is boot in, but there are 2 in. That in, 2 ins. So boot in, boot down in. You have to tell us the position. 1, 2, between 2 and 3. Between 1 and 2, you know, 1, 2, 3, 4. From the front, from the back, 1, 2, 3, 4. So it is 2 and 3, but here it is 1 and 2. So it will be buta 1 dash 1, 2 die in from the back. Do you understand? So that is how you name, you know, when you have double of those, you know, families. So propan 1, 2, 3 triol, we call it glycerol. Glycerol, that's the common name. And you have ethane 1, 2 diol, ethyl glycol. So that's another type. So the other one is 2HCHO. So how do you draw this? C, that's 4 bonds. H, then you have OH. You see these 2 bonds? You take the hydrogen. Just one takes H. This is how you write propanol. When you see something end with RCHO, this is how it is drawn. So this is just one carbon. What family is this? It is the al family, alkanal family. CHO, alkanal family. So just one carbon atom. It is methanal. Methanal, one carbon atom, methanal, the al family. So are we good to go? It is not in, no. In is carbon to carbon double bond. This is carbon to oxygen, not carbon to carbon double bond. So carbon to oxygen double bond with 1 hydrogen is al family. It is carbon double bond to oxygen and to OH is oic acid. This is what I'm saying. If they have it this way, this is oic family, alkanoic family. You get RCOH. Now let's go to number 3. Number 3, you have CH3, 1, 2, 3. Then the next C, you have double bond. So there's only one space for 1 hydrogen, and that's the hydrogen. Then C, C. You know, this is null family again. Why? Because CHO. And let's name it. So because the family is here, this has to be your carbon number 1. You know, if you start from this place, 1, 2, 3, 4, it will be 4. It will be 4. That will be the position of 4 null. And we don't want the highest, you know, high number for the family. Go with the lowest number for the family. That is the null family. Since you're having CHO, double bond for O, it is null family. So you go with the back 1, 2. You understand? So this will be the position number 1. Or let me write it. Just put your O here. So this is null family, and this will be position number 1 because the main decider. This is double bond. It's even from double bond to O. This is null family. This is in family, carbon carbon double bond. Now you will see what I wrote here. This is how the order of superiority. Whenever you see COH and CHO in a bond, COH becomes the main family. CHO return to, you know, a substituent. Whenever you see any of these ones with COH is what will be the family name. Others will turn to substituent. Do you understand? Whenever you see, this is the order of seniority. So when you see this one and this one, you know that this one is what you use to name that compound. This one is just a substituent. So look at, in the case of this one, there is the null family and there is the in family. So this is the main family. This will be a substituent. But in and an, they don't used to be a substituent. You know, we don't name them separately. So we look for a way to integrate them with the family name. Listen very well. When you have in and an in a family, in another family, you integrate their own names with that family name. So let's close our eye to this in. Let's just name this one. This one 1, 2, 3, 4. That will be butanal. Do you know? So we are supposed to say butanal, but no, butanal. But because this in family, we cannot say 2 in as a subsequent. So we have to integrate it into the family. So we call it, instead of buta, it is butuinal. So it is butuinal. Look at the way we clipped it. It is nal family, and we're having in. So instead of buta, it is butin. And we are using these two to tell the position of this in. So butuinal. Do you understand? So we clipped this instead of two vowels, so it becomes butuinal. So butuinal. Do you understand? So that is that. So for triple or double bond, you clip it, but for other ones, you don't clip it. You make it a substituent. For instance, let's look at this question number 4. So you will see that double and triple bond, you can clip it with the main family, but for other ones, you can't clip them with the main family. You have to use them as substituents. So the question number 4, you have C3 bond OH here, then you have H, then C. H2, then CO. So for the sake of clarity, let me be putting the O aspect. So anal family, because you have double bond O, C double bond O. You understand? So this is anal family. So you have two families here. You have the butanal, yes, you have the nal family, alkanal. I have the OH family. Look at the order of things. Which one is the senior here? CH is greater than OH. So CHO becomes the family. Longest chain, this is it. So 1, 2, 3. So this is propanal. Propanal. You don't need to say propan 1-al. Now I told you about propene. I don't need propane. No, it's always propene because 1 from the front, 2 from the back. 1 from the front, back, 2 from the front. Do you understand? So it's propene every time. So this one is just a propanal. Now OH, we cannot clip it. We cannot say propan, hydroxy, propanol. No, you can only do it for the likes of in and ein. Butuinal, something like that. But for the likes of other functional groups, they have to come out as substituents. So this one now, it is not more all as a family. In the family it is all alkanol. So as a substituent, it will be hydroxy. You understand? So what's the position? 1. That's wrong, because we have named this family as 1. This carbon will be 1 because of this family, so that the O will be on carbon number 1. So it means every of our naming has to be from the back, according to what we said. You remember? So 1, 2, 3. So this will be 3 hydroxy propanal. Are we good to go? 3 hydroxy propanal. You can't say 1 hydroxy because the family has already started moving from back. The main thing in the family is this CHO, and that's position number 1. Now let's go on to the 5th one. So for the 5th one, you have CH3. So let me just draw it. I see H, no, O, H, double bond O. So let's see, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this one now, you see. So you can see the family, null family. Is this one null family? No, null family is RCHO, meaning the C that is having this O has to be linked to H. Is this one linking to H? C, double bond O. Is it linking to H? No, it's linking to C and C. So don't think you have 2 null family. Don't think you have 1 null here, 1 null here. No, this one is CO. The O is now linked to R, an alkyl radical. It's linked to another, alkyl radical or something else. So it is not null. It's supposed to be on, the on family. C double bond O. This is the on family, RCOR. Just C double bond O, then you link to whatever you want on the right, link to whatever you want on the left. You understand? So that is the on family, not null. This is the only null you have here. RCHO. Everything HO. You get? So the longest carbon. Okay, so you have on and you have null. Which one is senior here? Of course, null. So this is the chain for null. So this on becomes a substituent. You cannot clip it. You only clip in and ein with other family. So 1, 2, 3, 4. That is butanal. With 1 null, with 1 null. So that's butanal. You understand? 4 in the family of alkanal. Then the position of this one. This is a substituent. So how do you call on when it's a substituent? It is oxo. Just call it oxo, like normal oxygen. So what is the position? Definitely, it cannot be 1, 2 because the main family is starting the counting from the back. Because that's where the bond is from. That is where the family edge is. So you have to start from back. 1, 2, 3. So that will be 3 oxo butanal. Are we good to go? So number 6. What's the number 6? So CH3, 1, 2, 3. C double bond O. 1, 2, 3. So the fourth bond CH and CH3. Definitely you need to be on. 1, 2, 3, 4. And the last CH3. Are we good to go? So CH3, CO. Since carbon can only take 4, oxygen is bivalent rather. So 2. It has to take 2 electrons. 1. Are we good to go? Just look at it. You should get it. So what family is this? The only family we are seeing here is the on. C to double bond O. So on the left side it should be an alkyl radical. On the left side alkyl radical methyl. On the right side alkyl radical. So this is the on family. This family. So the longest chain. So the first thing, select the family, and that's the family. You cannot call this carbon number 1 because it is not starting. Do you understand? Even though the family is on it does not make it carbon number 1. You understand? Because it still has the carbon attached to it. So this is 1, but this is the family. Do you understand? In the case of this one now, it is 1 starting. And even there's another carbon at the top. Do you understand? This will be 1. It will be 2. Butanal. Do you understand? So it does not mean the carbon that family is attached to will be the first carbon. No. If it is not starting, it can be the first carbon. You get? So because this C where the O is attached is not starting, it can be the first. What is at the back is the first. So this now it is butanon. But you have to tell us the position of the on because it is not on 1 now, it's on 2. So butan 2 on. Instead of writing butanon, you just split the non-bond and put the position because it is not on 1. So butanon. Then there is a substituent, that is the one that is not on the chain. What is not on the chain? This O is part of the chain because that's what makes it a family. So what's not part of the chain? This CH3. So the position. Now for you to have called this one 2, it means you consider it from the front 1, 2, from the back 1, 2, 3. So considering it from the front means since we have considered family from the front, every other thing we want to do has to be from the front. So we can't call this one 2. That's to be from the front 1, 2, 3. So now 3 methyl butan 2 on. Do you understand? 3 methyl butan 2 on. The first thing, the family butan 2 on because of the position of where the head of the family is. So the difference between this one is C double bond OH. This one is C double bond RR. You getting that? Let's go to question number 7. So we're almost done. Sorry, okay. So this is the order of seniority. I think I didn't add ethers to it. Ethers should come after OH in the order of seniority. So you can confirm that and include it. That is ethers. Yeah. Now let's go for question number 7. So this is C. So how do you draw this? See this. So when you have COH, so this is the drawing for COH. So how do you name this? This is the family. And since the carbon housing the family is 1 here, so it becomes carbon number 1, and this is the longest chain. Are we good to go? So this is 1, 2, 3 in the oic family, COH, alkanoic family. So that makes it propanoic. You don't need to say propanoic acid. You don't need to say propanoic because it cannot be propan2-onoic. If you put double point here, still 1 from it. Are we good to go? So propanoic acid. Question number 8. So it has no substituent. That's why I didn't talk about that. Number 8, we have OH. Okay, so let's draw it. C, just 2 carbons. This one pick O and OH. This one picks 1 hydrogen, that's 2 hydrogen, and then CB is space 1, 2, 3, 4. This is OH 1, 2, 3, 4. So what do you name this one? The family, you have 2 functional groups here: COOH, OOH, and OH. According to other things, COOH and OH, which one is the? So this senior is that, so it will be the family name. So this is the family name. What chain has that family? As longest, it's just this one. So that's 2. Carbon number 2 in the oic family, that is ethanoic. You don't need to call it ethanoanoic. Although we know this will be the carbon number 1 for it. Do you understand? Because it is the one holding the family. So you cannot say 1, 2, ethan 2 oic. No, the smallest is from the back. Ethan 1 oic, that is ethanoic. Are we good to go? So it needs to name this one. This one becomes the substituent. You can't clip it. If it's in, you can clip. You can say ethinoic. If it is double bond C that we are, you can say ethin. You can clip in with the other family, but no, for other OH alpha, you have to call their name. So for this one now, the position is 1, 2, because the head of the family is here, so we call this carbon number 1. So 1, 2. Do you understand? So that makes it 2-hydroxy ethanoic. 2-hydroxy ethanoic. Now let me do something. What if I have a carbon here? What do we have called it? So the family is CCOH. Are you getting it? But this is not the carbon starting the chain. This is the chain. This is not a substance. Since it is continuous. It's continuous. So this one would have been propan-2-noic acid. Do you understand what I'm trying to say? So propan-2-noic acid, then 1, 2. Then this one can be 3-hydroxy-propan. Do you get it? So you can't say 1-methyl, no, because this is the continuous. It is a continuous chain. So it's just this family that you now tell us the position from, that it is in the second number, second carbon atom. So propan 1, 2, 3, propan-2, propan-2-noic acid. Okay, that's what I'm trying to say. I'm trying to say that it does not mean where the family is will always be number 1 at all times. No, if it is starting, you can call it number 1. If it is ending, you call it number 1. So let's go to question number 9. Quickly, you have okay, this question number 8, question number 9. So naming this quickly: double bond C H H C O O H. So what do you call this family? You already know it. So this is the butanoic, and this is starting. So where the family is the starting point. So 1 is, this is also the starting point. That's what I meant. Where this carbon that is there has the family. So let's see this here. 1, 2, 3. So this will be 3 also butanoic acid. So for the last one, let's take the last question. Then we'll call it a day. So that is C. So double bond OH. So you have CH3. You have H. So what do you name this? So think the family, that's COOH. It's simple. Are we good to go? So that's propanoic acid. So position of this substituent 1, 2. You understand? That makes it 2 methyl propanoic acid. So thank you. We'll continue from here next time.